So in our previous class, we saw IBGP split horizon rule. We learned that to prevent duplication of update, which will end up in loop, BGP has got a rule saying route learned from one IBGP should not be given to another IBGP. The solutions to solve the problem if you're having many IBGP hops is to put VPN. It can be GRE tunnel or MPLS tunnel, or it can be a frame, whatever tunnel that you want to have. It can even be a VXLAN tunnel. But we are not in the MPLS class or any tunneling technology topic. We are in BGP. So the solution in BGP is to form neighbor with every other router in the topology, not just the directly connected adjacent router, but to every single router in the autonomous system, which we call it as full mesh. Now, there is also another solution which is called as route reflector, which I would like to emphasize in today's class. Route reflector. To understand this route reflector, we need more routers. So let me add another router here. And I'll also add another router. This one. I'd like to add another router here. That will be another autonomous system. And also I want okay, yeah, let's add another router here. Inside the autonomous system, I'll add another router here. See, forming full mesh is not a good idea. The reason is the process utilization will be very high. If I have 100 routers, I told you need to maintain 99 neighbors. 99 session is not that easy. In a large network, there will be millions of routes. You need to advertise to 99 neighbors. The same routes with many attributes attached to it is going to be too costly. So having something like VPN or this route reflector can really reduce the amount of process that will be consumed. Right. So this many is enough,
Okay.
and recording is resumed after building this topology now. Let me put the IP address in place as we planned. I'll call it back 55. Loopback 155. Interface G1/0. Done. And I would like to say router BGP 5000. And neighbor is 215.15.1. This is going to be the IP address on router 1 G1/0. Remote is 1000. And right memory. I'm not advertising any network in BGP. I'm just forming neighbor. Is this okay for you? Is any question with you?
No, no questions.
Fine. Let's put this. Likewise on R6. And this is going to be here. And this is going to be 6. So, and then this is going to be dot 2 is going to be the IP address on the router 2's G1/0. Remote address is 1000. Accidentally I gave 1000. So I have to change it in the previous configuration about 5. I said 100, not 100, is 1000. So our 6 configuration is ready to be deployed. R6 is also ready. R4 is already ready. Now I would like to do it on R7. We are not going to have full mesh, but we will have BGP on every router. I repeat, inside this autonomous system 1000, we are going to have BGP on every router, but not full mesh. Why we need to have every router? Because we don't have VPN. If you don't have VPN, then you need to enable BGP on every router to avoid a black hole we saw in the previous class. Are you convinced with what I'm saying?
Yes, sir.
Right. On router 7, I don't have any loopbacks now. And on F0, the IP address will be 10. 17, 17, and BGP is 1000. I made some mistake in the previous router 6 configuration. We need to go and check how many digits. Too bad. Boom, boom, boom. It didn't take it actually last time. I did not notice. Now it is taking. Show IPBGP summary. Okay. Fine. Router 6 is configured. Now router 7 is what we are trying here. Router 7 has got an IBGP neighbor 10, 17, 17, 1. This is what going to be the IP address on router 1. It's IBGP because the local as well as the neighbor autonomous system numbers are same. Because of the word remote is, we should not think as an EBGP neighbor. It is not. EBGP or IBGP is determined by comparing this number. If the numbers are same with the neighbor, then it is IBGP. If not, EBGP. Now I would like to paste this on router 7. Now let's go and on these routers. On router 1, I may need to add 2 more interface configuration now. 2 physical interfaces are newly added. They are F01 and G1/0. Interface F01 IP address will be 10.17.17.1. Let us verify the interface IP addresses. Are they as per the plan? Yes, they are. Now we also need to run OSPF only on the LAN side, IBGP side. We need to run OSPF on this link F01. Interface F0/1 IP OSPF 1 area 0 for the reachability. Likewise, we'll go to router 7 and run OSPF router OSPF 1 network 10. We don't have any loopback on this router, so this is enough. I'm expecting a neighbor between R1 and R7 shortly. Show IP OSPF neighbor. Yeah, it's in two-way state. It has already received the hello packet. See, router 1 is saying my name is 111111. But so router 7 has learned the name of router 1, which means it has already started communicating. Okay, now just mythic time. Let's go to router 1 again. And I would like to remove the BGP whatsoever we configured in the past. No router BGP 1000, so that you will not have any confusion. You will be clear in what we are doing. All the previous lab configurations are remote configuration. And now I'm saying router BGP 1000, freshly I'm including BGP, saying hey, you got a neighbor 10, 12, 12, 2, which is router 2. Remote AS is same, 1000. And you got neighbor 10, 17, 17, 7. Remote AS is 1000. And you got an EBGP neighbor 200, 15, 15, 5. Did I say 500 or 5? I would like to check. Show IP interface brief. Yeah, 5. So we go back to router 1 and say there's a neighbor called 5, and his autonomous system is 5,000. And I'm expecting an EBGP neighbor also. Yeah. Show IP OSPF, sorry, show IP BGP. Summary, you can see there's an EBGP neighbor, there's an IBGP neighbor. This router 2 is not yet configured, that is why it's still idle. Now let us go to router 2. Okay, now router 2 has got some BGP. I'll remove, I don't know whether it has got BGP. Show IP BGP. No BGP. Good, good, good. We need to additionally add one newly added interface called G1 slash C, which will have IP address 200.16.16.6. Remote. Sorry, what am I doing? I need to simply put the IP address. I'm not configuring BGP here.
Because I was wondering what's going on.
I went to BGP configuration under interface. That's very funny. Okay, now interface has got the IP address, and there is no need for OSPF in this interface because it's the BGP. Yeah, and now I should enable BGP router BGP 1000. You got a neighbor, Mr. R1, 10, 12, 12, 1, and you got another neighbor, Mr. R3, 10, 23, 23, 3. You got another EBGP neighbor, which is 200. Remote AS is 6,000. As soon as I hit enter, I'm expecting neighbors. 3 neighbors should be there. Sorry, 2 neighbors. Router 3 is still not on. Show IP BGP summary. One neighbor is already there. I'm expecting this neighbor. If I'm able to ping this address, there is some issue in reaching. I'll try to go to 6 and see what I have configured. Oh no, on router 6 I don't have key Ethernet. I have fast Ethernet 00. I have fast Ethernet 00. So I have to remove default interface G. Inserts. And I'll go to interface F00 and put that IP address. This IP address. And I'll bring it up and I'm expecting neighbor now. I'll go back to router 2 and try pinging this address. Ping. So the neighbor will come up now. Okay, it has come. So we got two neighbor, one is eBGP, the other one is FBGP. Now let's move on to router 3. And 4. I'm going to just remove BGP once in router 3 and put it back so that there won't be any confusion in understanding. Okay, I'm on router 3. I'm going to remove no router BGP 1000, and I'm going to say router BGP again 1000 with only one neighbor, which is only one IBGP neighbor, which is 10.23.23.2. Remote AS is 1000. And I'm going to have another eBGP neighbor, which is 200.0.0.2. Remote AS is 2000. You see, I'm not going to remove BGP on R4. I'm okay with what is already there. I'm simply forming neighbor now. I'm expecting neighbor shortly. Yeah, neighbor has come. So we got eBGP neighbor, we got IBGP neighbor. The topology is ready now. The topology is ready now with all necessary configurations. Before we get into the demo of route reflector, first of all, we need to understand route reflector and the rules. So let's try to spend some time in understanding this route reflector and how it solves the problem of IBGP split horizon rule, and also how it reduces the process utilization by avoiding full mesh. Yeah. So we got a wonderful topology to understand this route reflector. You see here, we got a route coming from router 4, and I have not opened the console of router 4, but I know very well that the other day we advertised. Did I? Let me check. Show IP BGP. This is the command that will show if something is, some network is learned from someone, or if some network is advertised from local. I see that there is nothing learned, nothing given, which means R4 is simply configured to form neighbor, no advertisement. Let us advertise these two networks only. I'm going to advertise these two networks on router 4. Okay. Right now, we don't have any network advertised. You see, just we are forming neighbor. This network will never be advertised. Show IP BGP summary. This is just a form neighbor. In OSPF, when you say network 200, 200, whatever, 200, 000, it forms neighbor as well as it advertises. In BGP, that is not the case. You have used this address only to form neighbor. This is not a network that someone can ping you. So you see, if you check in R3, routing table show IP route BGP, no routes. No routes. Show IP route BGP, there is no routes. But you already got a neighbor with R4. Show IP BGP summary. You have neighbor, but no prefixes learned so far. Prefixes received is null. Nothing received. So let us go and advertise some network. How to advertise? Router BGP 2000. Advertisement is same like what you used to do in OSPF, EIGRP, RIP. You're going to put the command network. It's the same. But the difference is, if the mask on the interface IP is not default, we must mention the mask. You see, 44, the default mask is 8, but we have configured 32. We have configured 32. So you must mention the mask. You see, 44, 44, 44, 44. If you don't mention the mask, it won't advertise, because it is trying to match this 44, 44, 44, 44, all 4 octets to match this. But sorry, this is trying to match only 44000 when you don't specify the mask. You don't have 44000 in the routing table. See, show IP route. You don't have 44000 in the routing table. You have 44, 44, 44, 44, 32. Because there is no match for what I configured, and I type show IP BGP, it says I'm not advertising anything. I'm neither learning anything nor advertising anything. So correction to be done is this. We must say the mask if the mask on the interface is not default. After I say this, if you see show IP BGP, you will find it. It says next stop is no one, which means what? I am the owner of this network. I am the owner of this network. No one else. I am advertising this. What about this 144? 144, it's a default mask. You see there, 16 is a default mask. 144 is class B. So I don't need to mention the mask. Router BGP 2000. You see, for 144, I no need to mention the mask. There's no need to mention the mask because it is class B. Now, if you go and verify show IP BGP, you're advertising this. But for this, when I say without mask, it didn't show up because the mask on the interface is 32, not 8. Did you understand the advertising part? When to use mask command?
Yes, sir.
Okay.
Yes.
Also,
Yes.
don't
Yes.
forget we
Yes.
need to use the keyword mask. You cannot straight away type 255.255. You should say mask and then the actual mask. All right, now I'm expecting this network on R3. Please focus R3. Show IP BGP now. If you see now, it says I received two prefixes. I have received two prefixes from this friend of mine, 200.0.0.2. And when I say show IP BGP, and these are the two prefixes coming from the autonomous system to 2000, and the next hop address is router 4's IP address. Yeah, router 4's IP address. Now we are going to check whether we see the same network on R2. On router 2, show IP BGP summary. Of course, we are learning two prefixes from IBGP neighbor, isn't it? For router 2, who is router 3? Router 3 is an IBGP neighbor. We are learning route from IBGP neighbor. Router 3 has given this, it is because router 3 has got these routes in the routing table. See, if the route is not in the routing table, router 3 will never advertise it to router 2. Router 3 has advertised it to router 2 because router 3 finds this is sweet. This is good. If router 3 don't like this, it would have not given to router 2. What do I mean by that? You see here, router 3 finds these two network as valid and best. You see, star and greater than symbol. Valid and best. Sweet. Most of the African countries, you know very well. And they like the food, they say sweet. Food is sweet. It may not be really tasting sweet, which means literally good food. Good network. Sweet. Okay, because it is sweet, it is found in the routing table. And when you go to router 2, you find that in the BGP inventory, there are two prefixes. Who is giving that? It's not R4 giving it. Who is giving this actually? R3. But when I type show IP BGP, it is not having the IP address of router 3. It has the IP address of who? Router 4. Why? Because according to what we have learned, BGP is autonomous system by autonomous system protocol. It won't show next hop as the next router. It will show next autonomous system address as the next hop. You remember that? It is an autonomous system by autonomous system routing protocol. So the next hop by default will be carried into IBGP. R4's address is carried into IBGP. You see, R4 address is carried to R2, isn't it? Okay. But
Yes.
the problem here is R2 don't have reachability to do this address. Because we don't know this next hop. Why didn't know? Why don't know? Because we are not running OSPF here. We are not running OSPF here. In the real world, we don't run OSPF here. But to learn route reflector, I want this address to be reachable. Or in another word, I want a next hop address which router 2 knows. You see, router 2 has got no route information about 200. Because there is no route about 200, in the BGP table it says, I got valid but not sweet. Not sweet. It's a food, but okay food, not sweet. Not best. Because this next hop is not reachable for me. So to make it reachable, what I want to do is I want to run OSPF here temporarily. But later when we learn another concept like next or hop self command, I will remove that OSPF. Alright, I'm just going to run OSPF for time being. Now after I say this, if you go back to router 2 and see this will turn greater than symbol here because we got the root in the routing table now. Earlier it was saying no root. Now because there is a route in the routing table, it is now sweet. Sweet. Only when it is sweet, it will be found in the routing table. Now router 2 also has learned the routes of autonomous system 2000. Router 2 has learned. What is the administrative distance of IBGP? No, no. That's
170.
the port number. 179 is the port number. Administrative distance is 200. You see 200? That is IBGP. What is the administrative distance of EBGP? 20.
20.
IBGP is 200. Okay, we got the route. Now comes the story, route reflector story. You see, there is a rule saying whatever you learn from IBGP, don't give it to another IBGP. Don't give. But there is no restriction in giving to EBGP. So what I am trying to say here is, in R6, if you go and check these networks, it will be available. But it won't be available in R1. If it is not available in R1, not possible to be seen in R5, nor in R7. So what I'm trying to show here is, the route from one IBGP is not going to another IBGP. It will go to EBGP. That's what I want to first prove. route learned from one IBGP will be given to eBGP. For that, I need to go to R6 and prove you that. You see, show IP BGP. I see here. I see the routes here. Who is giving this? Router 2 is giving this. From where it learned? It learned from 2000 autonomous systems. See, this is the AS path. That's why we call BGP as a path vector routing protocol. It shows the AS path. It shows the path. So a route learned from one IBGP will be given to eBGP. There is no issue. Are you okay with this? Route learned from one IBGP. Router 2 and router 3 has got IBGP. It can be given to eBGP. There is no problem. But will not be given to router 1 because router 1 is an IBGP. Let's go and check router 1. Show IP BGP. No routes learned here. No routes learned here. You see, they are neighbors. R2 is a neighbor. This is R2. R2 is a neighbor, but no prefixes learned because R2 is not giving. This is what IBGP split horizontal, isn't it? Now what I'm going to do is, I'm going to tell router 2, please give it to router 1. How? We call it as route reflector. I'm going to go to R2 and say router BGP 1000. See, I'm not adding additional neighbors. We're not making full mesh. I'm saying it is okay to give it to this neighbor 10, 12, 12, 1. Route reflector client. I'm making this as a route reflector client. You understood this command? We are saying it is okay, you can give. We are giving permission to override the rule, IBGP split horizontal rule. After I say this, I'll take you again to router 1. Please now you see, earlier you were seeing prefix length 0, prefix received 0, but now it says I received 2 prefixes. And when you check the BGP table, you can find those 2 prefixes. Yeah? And you see, this is the address of router 4. It is carried inside IBGP. eBGP's address is carried into IBGP. You agree?
Yes.
These things are going to come in the following chapter,
Yes.
which I'm going to teach you. So, IBGP will carry eBGP address. That's one thing here you're saying. Now, what is the expectation? You see, we have asked to reflect. Okay, because we have asked to reflect, the route has come here. Now, will the route be given to eBGP? Yes. It will be given to eBGP, so R5 will receive it. Will it be given to another IBGP? That we need to check. You understand what I'm asking? Okay, we need to check now.
No.
Yeah, let us check.
I don't think so.
Let us check. I need to go to router 5 to check whether we are learning the route. Show IP BGP summary. Yes, we learned the route. And when you check the routing table, show IP route BGP, you got those 2 routes. And when you type show IP BGP, it shows the path. Now let us go to router 7. Show IP BGP summary, new routes. New routes. So it reflects to R1, but R1 is not ready to give to a non-client. Do we have the rule here? You see, route learned from route reflector client. Is this a route reflector client? Yes. Or advertise to other RR client. No. It means, let me not confuse you. This is not the point that matches here. The route received from non-client or advertised to, no. Here, this is configured as a client to R2. Route learned from route reflector client or advertised to other route reflector client. Yeah, other route reflector client means, if you will have another route reflector configured here. So if I say, for example, I'll go to R7 and make it as a client to R7. Sorry, I'll make R7 as a client to R1. That is what meaning what? Route reflector client, other route reflector client. But R3 is a non-client. R3 is a non-client. It will be going to R3, but it won't come to R7 is not a
R3 or
non-client. I
R7?
repeat again. I want
R3
to
is
make
the
it one thing very clear here. There will be some confusion if you have some assumption here. Listen, this is what called as non-client. You know why? It is not because I did not configure as a client, it is a non-client. There is a different meaning in this. See, this is a client. Why I'm calling this as a non-client? Why not this? This is not a non-client. This is not a non-client. Why? See, whatever
okay.
R3 gave to R2, R2 was reflecting to this client, isn't it? That makes R3 to be a
Mm-hmm.
non-client. The information of R3 got reflected to R1, who is a client. So R3 becomes a non-client, but R7 is not. So it will give to
Okay.
other RR clients and non-clients, but it won't give to R7. So if you want on R7, you need to reflect again. See, R7 is never going to show you. So if you want R7 to have it, you need to go to R1 and say again router BGP 1000 neighbor 10 17 17 7 is a route reflector client. After you say this, you can now expect R7 to show those two prefixes and also in the routing table.
Mm-hmm.
Yeah, so we have still not completed route reflector topic. We have not completed, but this is the topic that we need to spend much more time. So I would like to stop here. We solved a problem by configuring two route reflector clients, one on
Okay.
R2, another one on R1. But still we have not covered all these three lines, but we will do it separately, right? I'll stop here.
Okay. That's fine.